So here we go. And the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So, do you have any questions over 8.3 or is it too early?
So far it was just a freshen up. So
Okay. So you're good?
I was like, yeah, I was halfway through the YouTube video and I understood everything.
Okay.
But like I said, it was a freshen up.
Okay. And if you need, check with me later. All right. So we're going to go on to section 8.4. And we're going to be looking at solving inequalities, compound inequalities, a variety of inequalities. First of all, I want to talk about the idea of this. Let's say that this is Nob Hill, oops, too many L's there, Boulevard, and this is 16th Avenue. What would this piece right here be?
Lights, hopefully.
Okay, but what piece of ground is this right here? What's that?
Cement? I don't know.
Okay, 16th Avenue crosses Nob Hill Boulevard. What do you call?
Oh, they intersect.
There you go, intersection. So is this piece of property part of 16th Avenue?
Yes.
Is it part of Nob Hill Boulevard?
Yes.
So the intersection of the two is that piece of property which they both share.
They both intersect.
Right, it's where they intersect. All right. Now, let's see. I've got Grand Funk Railroad and Sweet Comfort and the Guess Who. Just let me write these and then I'll talk to you about it. See, Barry Manilow, Star Wars, and the Guess Who. Now, when I and my wife got married, we united our record collection. And we had more records than this, but this is just enough to get the idea across. When we put our record collection together, what went to the yard sale?
One of the Guess Who?
Right. So that was the intersection. We both had that record. So in fact, we had an extra one, so we got rid of it. I don't know if that's what we really did, but you get the idea. Okay. So the intersection would be the record, the Guess Who. Okay. Now, the union would be all of my records along with all of Sue's records. Okay. So in the union, you'd have Grand Funk Railroad, Sweet Comfort, the Guess Who, Barry Manilow, and Star Wars. I wouldn't bother to list the Guess Who twice, but the union is all of it. The intersection is what they have in common. Okay. That makes sense?
Sorry, I was on mute and I couldn't unmute it, but yes, makes sense.
Okay. We're going to use the symbol U for union. I know there's a lot of pressure on you today because you're the only student there. So sorry,
No,
you'll get paid double today. All right. Intersection is basically an upside down U. So this symbol means union, means you take all of it. This symbol means intersection. You just take what they have in common. All right?
All right.
Okay. We have set A that contains 0, 1, 2, 3, 4, 5, and 6. We have set B that contains 4, 6, 8, and 10. We have set C that contains -3, -1, 0, 1, and 2. And finally, set D that contains -3, 1, 2, 5, and 8. And the hardest thing about this is making these braces. You've got parentheses, brackets, absolute value bars, and these are braces. Okay. Some of
What
them
does
better than
braces
others.
indicate? Just like a set of numbers, or is it like a
Yes.
specific?
Yes.
Okay.
These are usually used for sets. Okay. Let's say I want the intersection of A and B. So what is in the intersection of A and B?
So would it be all the numbers they have in common, or is it all
Yeah.
the numbers in general?
That's the question I'm asking you.
Well, when you said union, I wrote down all. When you said
Yes,
intersection, you said take in common. So I'm guessing all.
this is intersection.
Oh, intersection. So take in common. So
Right.
4 and 6.
Yep, that's correct. Yeah, intersection, what they have in common. All right. How about the intersection of A and D?
Let's see. A and D. 1, 2, 5, and that's it.
All right. How about the union of B and C?
So that would mean all. Would I have to list them in
Yes.
order? Let's see.
Yes.
B and C. So let's start off with -3, -1, 0, 1, 2, 4, 6, 8, and then 10.
Good job. And how about this? The intersection of B and C.
Let's see. I'm not seeing anything in common.
Right. So it's an empty set, or what's called the null set. And you can write it just with an empty set of brackets or a 0 with a line through it. Okay. Now what you don't want to do is do this. You don't want to put the 0 through with a line through it inside of the empty set, because then it's no longer empty. So either this or that. I tend to use this because it's easier for me to make that than it is for me to do that stuff. Okay. So
All right.
if you have nothing in common, empty set or null set. All right. Any questions?
No, so far.
So we've got union and intersection. The word or, where you have a inequality or another inequality, you have the word or separating them, means we want the union of the two. The word and means we want the intersection of the two. What I like to do is point out that the word and has the symbol for intersection right there in the middle of it. That's how I remember it.
Okay.
Anyway, so or means union, and means intersection. Union still means you take all of it. Intersection, you take what they have in common. Okay? Now, let's say we have the following situation. X is greater than -2, and X is less than or equal to 5. It says solve each compound inequality. We've got 2 inequalities there, if possible. Graph the solution set if one exists, and write it using interval notation. All right. Now, what I'm going to do is I'm going to graph each separate piece. The instructions don't require that, but my experience over the years has told me it makes it easier for students to see what's going on. If we graphed X greater than -2, we would have an open parenthesis at -2 and an arrow going to the right. Okay. if we graph x less than or equal to 5, we have a bracket at 5 saying that it includes 5, and again an arrow going to the left. Okay, so those are the separate pieces. Now we want the intersection. Keep in mind, this continues on forever, and this continues on forever in the other direction. So what do they have in common? Well, everything after -2 up to and including 5. After 5, the bottom one isn't included, and before -2, the top one isn't included. So what would that graph look like? You would have parentheses at -2, bracket at 5, and a solid line segment in between them. Okay. The answer would be x is what? Greater than -2 and less than or equal to 5. And interval notation would be parentheses -2, comma 5, bracket. So we've got the solution, the graph of the solution, and the interval notation of the solution. Do you have any questions about any of those?
No, so far.
All right, and again, recall, if it doesn't include the equals, it's a parenthesis. If it does include it, it's a bracket. Okay.
Okay.
All right, let's take a look at, let's see here, this one. We've got 5x minus 3 greater than or equal to 2, and 6 greater than or equal to 4x minus 3. Okay, I'm not keeping you from getting your moving done, am I?
No, it's okay. We're moving at 2, so we still have
Okay.
time.
All righty, making sure. Thank you, though. I appreciate your being here. Okay, so again, it's an and, so it's an intersection. I'm going to take each separate inequality and solve it for the variable on the left. So I'm going to add 3 to both sides here and get 5x greater than or equal to 5, divide by 5x greater than or equal to 1. I'm going to subtract 4x from both sides here, negative 4x plus 6 greater than or equal to -3, subtract 6, negative 4x greater than or equal to -9, divide by -4. Oh, what do I do when I divide by a negative number? I change the direction of the inequality sign. Remember that? Multiplying or dividing? Okay. And then I've got an and. So this is what I'm dealing with right there. Okay.
So far, so good.
I'm going to recopy that on the next page, so I've got a full page to work with. So x greater than less than or equal to 9/4. So I'm going to graph each individual piece. So x greater than or equal to 1, bracket at 1, arrow going to the right. X less than or equal to 9/4. Let's see, 9/4 would be 2 1/4. So that would be right about here. Bracket, whoops, bracket, and then arrow going to the left. Okay, and intersection. So it would be what? X would be greater than or equal to 1, less than or equal to 9/4. Interval notation, 1, 9/4. And then the graph, let's see if I can squeeze it in here. 0, 1, 2, 3. So you'd have what? From 1 to 2 1/4. Should be right about there. when you graph it in WebAssign, be really careful to try and get it as accurate as you can. So there's your solution, the number line graph, and interval notation. Any questions on that?
No, so far so good.
All righty. Another example, x plus 2 less than 1/3, oh, it's negative 1/3 x, and negative 6x less than 9x. And again, it's an and situation. All right. I'm going to solve the first inequality. Oh, let's see. I'm going to add 1/3 x to both sides. 1x plus 1/3 x would be 1 and 1/3 x, right?
I believe so.
Which is also 4/3 x. Okay.
So far so good.
Subtract 2, 4/3 x less than negative 2. Multiply both sides by 3/4. So I get x less than negative 3/2. All right with that?
Yes.
Let's see, the second one, I'm going to subtract 9x, negative 15x less than 0. Divide both sides by negative 15x greater than 0. Since I divided both sides by a negative number, change the direction of the inequality sign. So we get this. I'm going to recopy that on the next page. X less than negative 3/2 and x greater than 0. So x less than negative 3/2. Let's see, -1, -2, that would be right here, halfway there. And arrow going to the left, x greater than 0. Parenthesis, arrow going to the right, intersection. What do they have in common?
Nothing.
So no solution. All right.
Yes.
Next idea, we're going to look at what's called a double inequality. So up to now, we've been doing compound inequalities. We had two separate ones, and we either unionizing them or intersecting them. This is kind of like an intersection that's already happened. So we've got this situation, 4 less than or equal to x plus 3 less than or equal to 7. So we've got three pieces. We've got the left end, the right end, and in the middle. We want to solve it for the variable in the middle, but anything we do to the middle piece, we have to do to the left and right end as well. So for this one, I'm going to subtract 3 from the middle. So I'm also going to subtract it from both ends. So I get 1 less than or equal to x less than or equal to 4. Now, let's see, they want us to graph it and write it in interval notation. So the graph, let's see, 0, 1, 2, 3, 4. We're going to have a bracket at 1 facing to the right and a bracket at 4 facing to the left, and it filled in, and then interval notation would look like that. All right with that one?
Yes.
Okay, let's see. There's a certain one I want to find. Where is it? Here we go. Okay. -4 less than or equal to -2 times the quantity x plus 8 less than 8. Okay, so again, I want to solve for x in the middle. The first thing I'm going to do is distribute the -2 in the middle and get that. Then I'm going to come back and add 16 to all three pieces. So I get 12 less than or equal to negative 2x less than 24. Then I'm going to divide each piece by negative 2. So I get negative 6 and x and negative 12. But because I divided by a negative number, I'm going to change the direction of both inequality symbols.
Yes.
The problem is now this thing is kind of backwards because we always want it in its final form to be smallest to largest. So I'm not going to change the direction of the signs. I'm going to just pick that whole thing up and flip it around. For instance, okay, if you and I are comparing our ages, we could say that I am older than you. But you would say that you are younger than me, right? Same idea, just different viewpoint. So we could take this whole thing and turn it around and write it like that. You see what I did there?
Yes, I was literally going to ask you that when you got to the step right before we did.
Yep, and that's why I did this problem. So now there's our solution. Number line would look like this: 0, -6, -12. We'd have parenthesis, bracket, so parenthesis, bracket, and then interval notation would look like that. Okie dokies?
Yes.
All right, let's see here. Now I want to look at some union situations. X less than or equal to -2 or x greater than 6. In this case, each individual inequality has already been solved. Let's take a look at the graphs of them. X less than or equal to -2 would look like that. X greater than 6 would look like that. What does union mean?
Union means the opposite of the other one. So take all the
Okay, intersection,
I mean,
what they have in common. Union is you take it all.
take it all. So it'd be -infinity, comma -2 bracket, right? Or am I thinking, I don't know if I'm thinking the correct thing.
Let's do the graph first.
Okay.
So the graph would be that along with that. The interval notation would be that along with that.
Okay, yeah. I thought I was doing the correct thing in my brain, but I wasn't sure.
Let's talk about Hawaii. Who
Never been.
doesn't want to talk about Hawaii? Hawaii, the state, is made up of several islands. Okay. So for instance, there's the Big Island, there's Oahu, there's Maui, there's others, but anyway, so even though they are united as a single state, they are geographically separate. That's what's going on here. We want the union of two separate islands. So when we label them as a state, they still have to be separate. They're geographically separate. There's a gap there, okay? So we can't write it as a single interval. We have to use, and again, we use this union symbol. We have to say, well, it's all of that along with all of that. Likewise, the graph has two pieces, okay? Because even though they're united, they're still separate geographically. Does that make sense?
Yeah, it does.
Okay. And besides, who doesn't want to think about Hawaii, right?
Right.
Okay, now let's take a look at, let's see here, let's do this one. 2 times the quantity x plus 2 less than x minus 11, or negative x over 5 less than 20. So again, or we're talking union. Let's solve each inequality first. The one on the left, I'm going to distribute 2x plus 4 less than x minus 11. I'm going to subtract x from both sides. X plus 4 less than negative 11. Subtract 4 from both sides. X less than negative 15. All right, and then we'll bring down the or. Over here, I could multiply both sides by negative 5, and I would get x greater than negative 100. Okay, negative times negative is positive, and the 5's reduce out, but because I multiplied or divided, in this case, multiplied both sides by a negative number, you change the direction of the inequality symbol. Okay.
Yes.
All right, let's take those and recopy them. X less than negative 15, or x greater than negative 100. If I graph each individual piece, let's see, that's going to look like that. So everything less than negative 15. My graphs obviously are not to scale. X greater than negative 100. So what would the union be? It'd be all of that along with all of that. So what would you have there?
Would it be parentheses negative 100? Or wait, did I write that wrong?
You're thinking intersection. It's union.
Yeah, okay. Wait, so how did you get x is greater than negative 100? And then, did I write it wrong? I have x is less than negative 100. Oh wait, we multiplied by negative. Oops,
Change the direction. There you go. Okay.
my bad. I was like confused for a second.
But only a second. All right. We
Okay,
good?
let me write that. X, yeah, I wrote down the wrong sign.
Okay.
X is greater than negative 100. Okay.
So now, what is the union of this along with that?
Would it be negative, oh my goodness, negative 100, comma, I don't want to say infinity. I don't know.
Okay, well, let me ask you this. Let's look at the top graph. How far to the left is it going?
It goes forever.
And that's in the union.
Yes.
So do you want to start at negative 100?
Oh, wait, would it be negative infinity? No, I'm confused.
Yes, it would.
Negative
Between-
infinity to negative 15, or negative infinity to infinity?
There you go. Between the two of them, they've got it all. It's like that marriage made in heaven. And then it would look like that. That's a sad looking. So negative infinity to positive infinity would be the interval notation. So the union of those two would be all real numbers.
All right, got it.
Okay. Let's see here. Let's do one with decimals. Out. Here we go. Okay. Y plus 0.52 less than 1.05y, or 9.8 minus 15y greater than negative 15.7. Okay, so or it's a union. We're going to take all of both, but first of all, we need to solve for the variable on the left. Okay. Now, do you want to clear the decimals or live with them? It's up to you.
I don't mind either.
Tell you what, let's clear them. So the left inequality, I'd have to multiply by 100. Okay. So that would give me 100y plus 52 less than 105y. You see how I got that?
Yes.
All righty. I'm going to subtract 105y, which gives me negative 5y plus 52 less than 0. I'll subtract 52, negative 5y less than negative 52. I'll divide by negative 5, which means I change the direction. Now, since we had decimals, I'm going to write 52 divided by 5 as a decimal. 52 divided by 5 is 10.4. And I could leave it as a fraction or a mixed number, but I'm just going to go with a decimal. Okay?
Okay.
The one on the right, we'll multiply both sides. Whoops, that needs to be over here by 10. So I get 98 minus 150y greater than 157.
Yes, got it.
Oh, you know what? There was a minus sign there, though, because I got sloppy, and so I forgot that. So that's a negative 157. Okay. Now I'm going to, let's see, I'm going to subtract 98 from both sides. So negative 150y less than negative 255. I think that, yeah, that's right. Divide both sides by negative 150. Change the direction of the sign. Let's see, 255 divided by 150. 255 divided by 150 is 1.7. So I've got y less than 1.7. So now I've got this to deal with. Okay. Again, here I divided by a negative, so I changed the direction of the inequality sign. Any questions?
No, so far.
All right. Y greater than 10.4 or y less than 1.7. So if we graph y greater than 10.4, we'll call this 10.4. So it's going to look like that. And then y less than 1.7, we'll call this 1.7. It's going to look like that. Union. So we're dealing with that Hawaii situation again, aren't we?
Yes.
Our number line would go, let's see, 0, 1.7, 10.4, parenthesis, filled in, interval notation, 1.7, comma, 10.4, parentheses on both ends. All righty?
When you said or, didn't that mean, or maybe I'm confused, negative infinity to 1.7 and then, or am I thinking and?
Oh. I switched from or to and. I got in a hurry, looked at the time and panicked. My bad.
No worries.
Oh, plenty of worries on my end. You are absolutely
worries.
correct. So let me do this. Let me erase my horrific mistakes there. Too bad we can't rewind the video. Here I am on YouTube. The whole world knows I screwed up. I'm so nervous. Okay.
You're fine.
I know. So the union would look like this. Let's see if I can get it right this time. 1.7, 10.4. So we've got that piece and then that piece. See, that's why you're here. If I'd done this on my own, there would have been nobody to point out my error. And then the union and interval notation would be negative infinity to 1.7 parentheses, that union symbol, parentheses 10.4 to infinity. So we've got two Hawaiian islands, so to speak.
Perfect.
All righty. One more problem. See if I can redeem myself and get this last one right. Okay. This is basically, I think this is just the author's attempt to get you used to more function notation. And so what they have is this. It says -6 less than f of x less than or equal to 0, where f of x equals 3x minus 9. All we're going to do is take that and substitute it in the place of f of x. Okay, so that's going to give us -6 less than 3x minus 9 less than or equal to 0. Like that. See what we did there?
Yeah, so far, so good.
So solving for x in the middle, we're going to add 9 to all three pieces. 3 less than 3x less than or equal to 9. Divide everybody by 3. 1 less than x less than or equal to 3. Let's see. There's our solution. We'll go ahead and graph it. Let's see here. 1, 2, 3. 1, 2, 3. Parentheses at 1. Bracket at 3. Solid line segment in between. And then interval notation looks like that. So really no different from the other problems. We just need to make this quick substitution to replace f of x with 3x minus 9. Okay. You good to go with that?
Yes.
Well,
Yes.
thank you so much for being here. And
All right.
we'll close this up, stop the recording.